All right, last problem on the Chapter 18 PowerPoint, Slide 9. This is question number 5, and I've added a few. This is a long problem. It's a titration problem. We've got a solution of formic acid in 25 milliliters of water, and it requires 20.67 milliliters of 0.175 molar sodium hydroxide to reach the equivalence point. We've got a lot of stuff to figure out here. We want to know the concentration of formic acid in the original solution. We want to know the concentrations of protons, hydroxide, and formic acid at the equivalence point. We want to know the pH at the equivalence point. We want to know the pH at 10 milliliters of added base, and we want to know the pH at 30 milliliters of added base. So let's begin just by figuring out what is the concentration of formic acid in the original solution. This one is really kind of easy. It's like a review, sort of. I'm going to start. Well, how am I going to start this? I'm going to start and say, you know what? I know I have 0.175 moles of sodium hydroxide in every liter. That's what that tells me. And I had to add this much of the sodium hydroxide solution. So that's 0.02067 liters. So that tells me my moles of sodium hydroxide. Formic acid is a weak acid, and it reacts with sodium hydroxide in a 1-to-1 molar ratio. It's going to give me water and the formate anion. So I know then that for every 1 mole of sodium hydroxide, I'm going to have 1 mole of my weak acid, formic acid. So I will know the concentration of formic acid in the solution. Well, if it took this much sodium hydroxide and I had 0.025 liters of the formic acid solution to begin with, look how all this works out. Moles of sodium hydroxide cancels moles of sodium hydroxide. The liters of the sodium hydroxide solution cancels the liters of the sodium hydroxide solution, and I have moles of my weak acid, formic acid, per liter. That's molarity. So now I just got to do the math. So let's see. What's all that going to come out to? 0.175 times 0.02067 times 1 divided by 1 times 1 divided by 0.025. So that's all going to come out to 0.145 molar of formic acid. Sweet. That's the first part. What was part B? Part B says, what are the concentrations of protons, hydroxide, and formic acid at equivalence? Okay, what's going on here? So we've made it all the way to the equivalence point. So what happened at the equivalence point? Well, that means we've added enough hydroxide to completely react with all of the sodium hydroxide solution. Sorry, we've added enough of the sodium hydroxide solution to react with all the formic acid. We just figured out, well, maybe I didn't figure out the moles, but we could stop there. Let's go back here, and let's just look at how many moles of the stuff we had. So if I had 0.175 moles of sodium hydroxide per liter, and I added 0.02067 liters, that would be 0.00362 moles of hydroxide added. That should be the same as my moles of formic acid. I'm just going to check it just for the heck of it. So let's see. I had 0.145 moles of formic acid per liter. That's what I figured out here. And I have 0.025 liters. Well, this times this better be close to that, or I did something wrong. 0.145 times 0.025. Look at that, that's pretty close. 0.00363 moles of formic acid. So there we have it. So I know I did that right. Now, why was I figuring that out? Let's go back to part B here and see what I was doing. Well, I want to know the concentrations of H plus, hydroxide, and formic acid at equivalence. So at equivalence, I've added these two equal amounts. So that means this reaction has gone to completion. That's exactly what that means. So that means I started with 0.00362 moles of this stuff and 0.00362 moles of hydroxide. And bam, those all reacted with each other. Those are all gone. I got 0.00362 moles of water, and that's not going to mess with the pH. But I did get 0.00362 moles of this stuff. This is going to mess with the pH. So let's see, I have of my weak base 0.00362 moles of the formate anion, whatever that is. Wonder what its concentration is. Well, let's see. We had 20.67 mils of the base that we added to 25 mils of the acid to begin with. 20.67 plus 25. That's going to be a total of 45.67 milliliters. So I better divide this by 0.04567 liters. So I know my concentration of weak base, 0.00362, divide by 0.04567, 0.0793 molar of the formate anion. What was I supposed to do? I think I was supposed to find concentration of everything. Yep. So I need to find the concentration of protons, hydroxide, and formic acid at equivalence. And at equivalence, we have this concentration of the formate anion. So that's where we're going to start for part B. I told you this was long. Okay. All right, so I have 0.0793 molar of my weak base, the formate anion. This is going to react with water. Let's see, it's going to grab a proton. We're going to get HA, and we're going to get hydroxide. And what's Kb for the formate anion? Well, let's get out my chart here. Formic acid and the formate anion. Okay, there it is, Kb. Let's use Kb for the formate anion, 5.6 times 10 to the negative 11. All right, Kb, 5.6 times 10 to the negative 11. That's going to be helpful. So let's see, initial change equilibrium, 0.0793. We don't got to worry about water, none of this, none of this. We're going to lose some of the formate, 0.0793 minus x. We're going to get x of each of these, and I can write concentration of this times the concentration of this over the concentration of this is Kb. So I'm going to get x squared over 0.0793 minus x is 5.6 times 10 to the negative 11. We're going to say this is going to be 5% or less of this. Let's see what that is. Just want to do it. 0.0793 times 0.05. So x has to be less than 0.004, basically. That's going to be less than that. So let's multiply both sides by 0.0793 to cancel this and this. Yeah, I'm going to take the square root of this side, and I got to take the square root of this side to get x. So let's see. 5.6 times 10 to the negative 11, where's that plus or minus over here, times 0.0793, and I'm going to take the square root of that. Where's my square root button? There it is. Shift. There. X is 2.11 times 10 to the negative 6 Yeah, that's less than that. We're in good shape. Now, you might remember, what were we supposed to do? Man, we're only on part B. We were supposed to find proton concentration, the hydroxide concentration, and formic acid at equivalence. Let's also find the pH, so we'll do both B and C together. So let's see. I want to find this. I want to find this. And I want to find this. And I want to find the pH. Okay. Well, what is X? Hey, look, that's both this and this. Is that right? Is that what I wanted to find? I sure is. So we can just write those right in there, can't we? 2.11. Oh, not that one. This one. 2.11 times 10 to the negative 6 molar. Same with this guy. What's my H plus concentration? Well, I don't know. I'm going to find the POH first because that's easy. POH is minus log of hydroxide, which is the minus log of this number here. So let's see. 2.11 times 10 to the negative 6. Yep. And let's take the log of that and make it positive. Oh, that should say POH, shouldn't it? Yep. So my POH is going to be 5.676. I'm going to go out to another decimal there. That's my POH. So my pH should be 14 minus this. So let's just see, make it negative. And I'm going to add 14. So my pH is 8.32. And I still haven't found my proton concentration. Well, that's just going to be 10 to the minus pH. So let's see, I'm going to make that negative. I'm going to take 10 to the power of 4.74 times 10 to the negative 9. Let's see if everything makes sense. I've got a weak base that's present, and I've got a basic pH. I've got more hydroxide than I do H+. That makes sense. I think this problem is solved. Part D. What is the pH at 10 milliliters added base? Oh boy, here we go. 10 milliliters added base. What's the pH? Okay, let's say I only added 10 mils of base. So I got to take my 0.175 moles of hydroxide per liter, that's from this, times 0.01 liter. What's that come? Well, that's easy to do. 0.01, so it's going to be 0.00175 moles of hydroxide added, right? I think that's right. How much formic acid? Well, we already figured it out, but I'm going to do it again. The formic acid would have been, we found out that concentration before. I don't want to calculate that again. Where is it? Here it is. That many moles present. Remember that? We've calculated that. We found out this. Yeah, that's good. So 0.00362 we'll use. So I have 0.00362 moles of my weak acid before I do the titration. My acid will react with the hydroxide. It's going to form water, and it's going to form the anion. So let's see. 0.00362 moles of this, 0.00175 moles of this. These will completely react as far as they can. This is the limiting reagent, so this is all gone, and it's going to form 0.00175 moles of my conjugate base. We're going to lose 0.00175 moles of my acid. 0.00362 minus, let's try that again, 0.00362 minus 0.00175, so I got 0.00187 moles of my acid. Now I can use my buffer equation, because that's what I got. So pH is pKa plus the log of my weak base amount, 0.00175, over my weak acid, 0.00187. Oh crap, I don't know the pKa. Well, let's look up the Ka of formic acid. 1.8 times 10 to the negative 4. So the pKa will be about 4. Let's figure it out exactly. pKa is a negative log of the Ka. So my pKa is going to be 1.8 times 10 to the negative 4. Let's take the log of that, make it positive. 3.74 is the pKa of formic acid. Woo! So my pH is going to be 3.74 plus the log 0.00175 divided by 0.00187. 0.00175. Divide that by 0.00187. Let's take the log of that. We're going to add that to 3.74. So my pH will be 3.71 at 10 mils of added base. We're almost home free, folks. Last one here. What's the pH at 30 mils added base? Well, here, this is going to be easy. I know you're not believing me, but this is going to a piece of cake. This won't take long. At 30 mils added base, I know I've added an excess of this. Let's see, 30.00 mils minus 20.67 mils required to get me to equivalence. 30 minus 20.67. That means I've added an excess of 9.33 milliliters of hydroxide. So, I have 0.175 moles of hydroxide per liter, and I added an excess of 9.33 mils. So that's 0.00933 liters, is it not? I think that's right. So let's see. 0.175 times 0.00933. That's 1.63 times 10 to the negative 3 moles of hydroxide in excess, and a total of, let's see, 30 mils plus 25 to start. That's 55 mils, 0.055 liters. So I'm going to divide this many moles divided by 0.055 liters. So there's my hydroxide concentration in excess. So let's see, my concentration of hydroxide in excess, that's what's going to drive the pH, is going to be 0.0296 molar. I want to know the pH. Let's find the POH first, which would be the negative log of that. Let's see, the negative log of hydroxide. Just hit the log button here. That's 1.53. That's my POH. So add it to 14. Told you it'd be easy. My pH is 12.47, baby. 12.47, and we are done with that problem.